question is that maximize z is equal to y of x1 plus x2 plus 1 by 4 x3, right? Subject to 4x1 plus 6x2 plus 3x3 less than or equal to 3. Thrice of x1 minus 6x2 minus 4x3 less than or equal to 1. So this is 8. Sorry. And nextly we have y of x1 plus 3x2 minus 5x3 less than greater than or equal to 4, and x1 x2 x3 greater than or equal to 0. So this is the numerical that we have got, and no, we have to solve it by two-phase method, two-phase simplex method. So let's try and solve this numerical, right? So starting with the answer part. So is the given numerical in the standard format? Yeah. So we don't need to convert it into the standard format. We can directly start with the phase one, right? So the given numerical is in standard form. That is in standard form. So let's start with phase one, and in phase one, what we do is we create a artificial objective function, right? So artificial objective function is to be created, which will be what? It will be minimize w is equal to some value. So firstly, let's address the constraints, and then we'll be moving to the artificial objective function. The subject to. So what are the constraints? So firstly, 4x1 plus 6x2 plus thrice of x3, and then if we have to remove the inequality sign, it is less than or equal to inequality. So we'll have to add the slack variable here, and it is equal to 8. The second inequality we have is 3x1 minus 6x2 minus 4x3. Again, it is a less than or equal to inequality, so only one slack variable is sufficient here. And lastly, we have twice of x1 plus thrice of x2 minus 5x3. Now it is greater than or greater than or equal to type of numericity. So here we will have minus s3 plus a1 is equal to 4. So we can write x1 comma x2 comma x3. No, then we can write s1 comma s2 comma s3 comma a1 should be greater than or equal to 0, right? So now we can construct our artificial objective function properly. It will be what? It will be 0x1 plus 0x2 plus 0x3 plus 0s1 plus 0s2 plus 0s3 plus a1. So this is our artificial objective function, which is to be minimized, right? So let's move ahead and convert it into the tabular format. So here we have CB, CJ, then we have basic variables x1, x2, x3, s1, s2, s3. Then we have it as a1, and then our solution. So it is solution here. So x1, x2, x3, s1, s2, s3, and then we have it as a1 here. So now coefficient of a1 is 1, other than all here it is 0, right? So there are 3 constraints, so we'll be having 3 variables, basic variables in all the iterations, right? So firstly, the CB value here, CB value, okay, firstly the variables, so here it will be S1, then it will be S2, and here we have A1. So coefficient is 1 here, 0, 0, here, right? So putting the values 4, 6, 3, 1, 0, 0, 0, and here 8. Then we have 3, minus 6, minus 4, 0, 1, 0, 0, and 1 here. And then we have it as 2, 3, minus 5, 0, 0, minus 1, 1, and 4 here, right? So we have Zj, Cj minus Zj, right? So what we can write here is 2, 3, minus 5, 0, 0, minus 1, 1, and here again it is 4. And Cj minus Zj will be 0 minus 2 is minus 2, minus 3, it is 5, 0, 0, it is 1, it is 0. So here what we require is, all Cj minus Zj values should be greater than or equal to 0. It is a minimization function. So all Cj minus Zj values are not greater than or equal to 0. Hence, iterate. So here, what is the criteria for choosing the key column? The maximum value with a negative sign. So here minus 3 is that particular value, and this is the row that we are going to, sorry, this is the column that we are going to consider, right? So let's move towards a ratio column. Ratio 8 by 6, so that will be 4 by 3. Here it is 1 by 3, okay, sorry, 1 minus 1 by 6, and here it is again 4 by 3 only, right? So there is a tie amongst this entering variable, sorry, tie amongst the leaving variable. In afternoon lecture I am going to tell you how this tie is to be solved, but as of now that we have to convert this problem into a case 3 problem. So what I am going to do is, I'm not what is the case if there is a tie between the leaving variables, and if one of the leaving variable is your artificial variable. So if it would have been a normal circumstance, हम लोग क्या करते, तो इसको ही लिविंग वेरिएबल कर देते, पर अभी के लिए हम लोग क्या करने वाले, अगर मैंने इसको एलिमिनेट कर दिया तो हम लोगों को केस 3 का प्रॉब्लम नहीं मिलेगा, और मेरे पास केस 3 का दूसरा प्रॉब्लम, I didn't come across some different problem which was for case 3. So what I did was, I particularly, I'm not going to consider this particular thing, okay? I'm going to say that this particular variable is living, right? The right approach is what? Right approach मतलब क्या होगा, आपको a1 ही निकालना पड़ेगा, that is the right approach. But I have to show you how the case 3 calculations are to be done, and for that I require a1 to stay, right? So what I have done here is that I have instead of a1 I have removed s1. Ultimately this is the numerical, इसका आंसर क्या आने वाला है, सेम ही आने वाला है, कुछ भी करो आप तो उसका आंसर सेम ही आने वाला है. But just for the sake of making you understand what happens if for case, we are creating a case 3 scenario, right? And case 3 scenario will create it only if there is basic variables amongst this. So I'm creating a case 3 scenario, and hence I'm making s1 variable to live out. It would have been a normal problem, तो मैं क्या करता, a1 को ही निकाल देता, क्योंकि टाई हो रहा है और मुझे आर्टिफिशियल वेरिएबल चाहिए नहीं, ठीक है, तो मैं आर्टिफिशियल वेरिएबल को ही निकाल देता. पर अभी मुझे आपको समझाना है, इसलिए मुझे आर्टिफिशियल वेरिएबल वहां पे चाहिए, तो इसलिए मैंने क्या किया, इंस्टेड ऑफ a1 what I have done is I have removed s1, I have made s1 to live. So this becomes, now what this becomes, my key row. Anyways, the answer is going to remain same only. The final values are not going to change. So now what I'm going to do here is that I'll be directly creating a new variable directly creating new variables in new value table, right? So I won't be redrawing this table again, otherwise it will be again a waste of time. So I'll be drawing a table in which directly the new values are there. You can practice at home when you study this numerical, right? So the numerical will also be sent today on your Google Classroom as well, so that you can start studying the numerical. So CB, CJ, okay, I didn't. CB, then I have a CJ. I can write basic variables x1, x2, x3, s1, s2, s3, and we have a1, and then we have solution. Right, so this is solution x1, x2, x3, s1, s2, s3. This is a1. We have coefficients written according to the artificial objective functions. Right, so now directly I will be coming out to the new values. Here we have removed s1 and x2 is getting entered, so other two variables are going to remain same only. The coefficients are 0 0 only here, so the new values come out to be like this in the key row, and for non-key rows the values are 7 0 minus 1 1 1 0 0 9. Here it is 0 0 minus 13 by 12 minus 1 by 12, 0 minus 1 1 and 0. So if we move towards zj, so it will be 0 0 minus 13 by 12 minus 1 by 12, 0 minus 1 1 and 0, and cj minus zj value will be now here. 0 minus 0 is 0, 0 minus 0 is 0. Here it will be 13 by 12, here it will be 1 by 12, here it will be 0, here it will be 1, here it will be 1 minus 1 is 0. So now if you see, all cj minus zj values are greater than or equal to 0, and we can hence proceed to your phase 2, right? But in phase 2 now what we have to see is that what is the value of w minimum, right? So w minimum here is 0, so w minimum here is 0, and we have to check if artificial variable is amongst the basic variables, right? So these are our basic variables, and here you can see here the artificial variable is amongst our the basic variables, right? So I can write a1, that is artificial variable, is amongst basic variables. Now what we have to do here is that we have to think of the objective function, right? A normal objective function. So our normal objective function, which is maximize z is equal to what? Maximize z is twice of x1 plus x2 plus 1 by 4 x3, right? Other all will remain 0 only, 0 s1 plus 0 s2 plus 0 s3. Now previously what we did was we considered the a1 coefficient, we kept it as 1, but now for this for case 3 we are also going to keep the coefficient of a1 as 0. Now what has happened is that, see, in your case 2 there is no artificial variable, so there is no artificial variable, hence in phase 2 column you do not take the column for your artificial variable. Now but here what has happened is that your artificial variable is amongst your basic variable. So what we'll have to do is that we'll have to make this artificial variable 0 by hook or crook, right? So we have particularly decided that by hook or crook we have to do. So why to do much calculations? Let in objective function only, let assign 0 value for this object for your artificial variable. So if it would have been like now here it is one artificial variable, there can be two artificial variables, right, in your basic variables. So for both of them your coefficient will be 0 0 only. Are you getting or not getting? So anyhow we have to eliminate this artificial variable. So what we have done is that we have in objective function only, we have taken it as to be 0 only. Everyone is getting this, right? So I'm hoping that you have got this, or you can ask me after we finish this numerical, right? So CJ here basic variable. So we have now we have x1, x2, x3, s1, s2, s3, and solution. So now a few of the people that made mistake in yesterday's homework numerical, they can kindly put attention here what has happened. So the variables are here only x1, x2, x3, s1, s2, s3. We can even take a1, right? So let me particularly to make this as a1 only. a1 we can make, and then we can keep it this as solution. तो a1 का कोएफिशिएंट कितना है 0 है, s3 का कोएफिशिएंट 0, s2 का कोएफिशिएंट 0, s1 का कोएफिशिएंट 0. Here it is 2, 1 and 1 by 4, right? So now what I can do is that there are again three variables to consider, 1, 2 and 3. Now what we do in phase 2 is that we copy all the all the values, right? So by what we do is we particularly write down the variables, that is x2, s2, and here it is a1, right? Now what are the coefficients according to your new objective function? It is x2 का कोएफिशिएंट 1 है, s2 का कोएफिशिएंट कितना है 0 है, a1 का कोएफिशिएंट कितना है 0 है, right? Now we have to copy all the table as above in your phase 2. तो ऊपर का टेबल और नीचे का टेबल आपका सेम दिखना चाहिए, right? So what I'm going to do now, you can see. So I'm just copying 2 by 3, 1, 1 by 2, 1 by 6, 0, 0. Here also it is 0, and even the solution value we have to copy 4 by 3, right? Similarly, everything just as above, 7, 0, minus 1, 1, 1, 0, 0, and 9 here. Nextly, it is 0, 0, minus 13 by 12, minus 1 by 12. It is 0, minus 1, 0, and here it is 0. Now up to here we have copied every value. Then we can calculate Zj and Cj minus Zj. Now the values of Zj here can be given as 2 by 3, 1, 1 by 2, 1 by 6, 0, 0, 0, and 4 by 3. Similarly, we can find out Cj minus Zj values. So 2 minus 2 by 3. What is the value of 2 minus 2 by 3? It comes out to be 4 by 3. Right? So again, 1 minus 1 is 0. 1 by 4 minus 1 by 2 is again your 1 by 2 only. So sorry, yeah, it will be 1 by 4 minus 1 by 2 minus 1 by 4. Sorry, minus 1 by 4. So 0 minus 1 by 0 minus 1 by 6 is minus 1 by 6. Here it is 0. Here it is 0. Here it is 0. Right? Now what is this? Now here you should remember this is a maximization function. Phase 1 was your complete minimization. So here all Cj minus Zj value should be less than or equal to 0. Is it happening here? No. So it is not happening. Hence we'll have to iterate, hence iterate further, in that case we have to, now it is a maximization function, so what we are going to identify a maximum positive value. So maximum positive value, here there is only one single value, which is 4 by 3, and hence this appears to be your key row, right? So 2 by 3 is 7 and 0. We'll also have to put the ratio column here. I'm sorry that we don't have space. Ratio, okay. So the ratio values here particularly are 4 by 3 divided by 2 by 3. So the ratio value will come as 2. Then it is 9 divided by 7, that is 9 by 7. And here it is 0 divided by 0. So it will be what? It will be infinity only. No? So we can't consider this particular thing. Right? So now what we want is that we have to select the living variable. So 2 and 9 by 7. So इसमें से जो है 9 by 7 is a living variable. And what you can do is, you can mark this key row properly. Now your key element is 7 and key row we have identified, key column we have identified. We can move ahead and we can construct the table with new values. So I won't be repeating this table again. I'll be just drawing the table with new values, and let's see what happens then. Okay, so here we have CB, CJ, basic variables, X1, X2, X3, A1, A2, sorry, X1, X2, X3, S1, S2, X3, A1, and here we have it as solution, right? Solution, right? So this is X1, X2, X3, S1, S2, S3, and this is your A1. So this is 0, 0, 0, 0. We have it as 2, 1, 1 by 4. Right? So now the new values, the new variables were, entering variable was X2 instead of, which was the leaving variable, instead of, X1 is the entering variable instead of S2, and here it is A1. So 0, X1 का 2 है और X2 का coefficient यहाँ पे 1 है. So the new values are like this. You can try it at home. It's very easy now. 42 minus 1 by 7 minus 13 by 12, 1 by 14, 1 by 7, minus 1 by 2, minus 2 by 21, 1 by 7, 0, it is 0, 0, 1, sorry, minus 1, it is 0, 0, 1, it is 10 by 21, we have 9 by 7, and then we have it as 0, right? So these are the new values that we have, and depending upon that, we can move ahead. So we have ZJ, and we have to find out CJ minus ZJ, right? So it is, the ZJ value we can say it is as 2, 1, 13 by 42, 5 by 14, 4 by 21, and we have 0, 0, here it is 64 by 21. ठीक है, so here it is 0, 2 minus 2 is 0, 1 minus 1 is 0. Here we get minus 5 by 84, then it is minus 5 by 41, minus 4 by 21, then we would have a 0 and 0. So here, this is a maximization problem. All Cj minus Zj values should be less than or equal to 0. Is it happening here? Yeah, it is happening. So hence optimal solution is reached. Right? So we have to find out x1, x2, x3 and zmax values. So here the value of x1 comes out to be 9 by 7, right? So it is 9 by 7. X2 value, yeah, it is there, it is 10 by 21. So it is 10 by 21. X3 is not amongst the basic variables, so x3 value is 0 and zmax value is here what? It is 64 by 21. So this is how the case 3 is to be solved. Now the basic difference here, what is happening, though there is an artificial variable among the basic variables, what we have taken care is that we have taken, or no, we have made the a1, the coefficient of a1 as 0 in the objective function, so that it won't get appear again and again.